Between January 22nd and January 24th, 2016, a low-pressure system moved northeast along the Atlantic coast and produced continuous snowfall across the urban corridor stretching from northern Virginia through Maryland, Delaware, Pennsylvania, New Jersey, and into New York. The affected region contained approximately 80 million people distributed across metropolitan areas designed for high-volume vehicular and rail transit. Municipal snow removal infrastructure in Washington, Baltimore, Philadelphia, and New York operated under protocols calibrated for typical winter precipitation events, storms delivering 6 to 12 inches over predictable durations with clearing intervals between bands. Weekend conditions normally reduced commuter traffic volume while maintaining essential services and commerce. The Eastern Seaboard Urban Corridor functioned through coordinated transportation networks supporting population densities exceeding 10,000 people per square mile in core districts. Road systems carried daily vehicular volumes in the hundreds of thousands. Subway and commuter rail networks moved millions. Electrical distribution relied on above-ground transmission lines in suburban zones surrounding dense urban cores. Retail supply chains operated on scheduled delivery intervals. Healthcare facilities maintained staffing through shift-based employment, requiring reliable transit access. Snow removal capacity existed as mechanized fleets sized for historical storm frequency and accumulation averages. Plow trucks, salt reserves, and personnel rosters reflected budgets calibrated to manage winter weather within established parameters. The infrastructure assumed storms would remain within operational thresholds that permitted continued function even under adverse conditions.
On January 21, meteorological observations documented a low-pressure center forming off the Carolina coast as Arctic air moved southward over the continental interior and encountered warmer Atlantic surface temperatures. The thermal gradient intensified cyclonic rotation. Satellite imagery showed cloud structure organizing around the developing center. The system began tracking northeastward along a path parallel to the coastline. Atmospheric moisture drawn from ocean sources fed into the circulation. Upper-level wind patterns positioned the storm to maintain proximity to the densest population zones along the Interstate 95 corridor. Forecast models projected the low-pressure center would move slowly while maintaining organizational structure. The projected path and speed indicated prolonged precipitation duration over stationary geographic areas, rather than rapid system transit that would limit accumulation totals in any single location.
Snowfall began across the Washington metropolitan area during the late morning of January 22nd. Initial precipitation rates measured 1 to 2 inches per hour. The snow shield expanded northward through the afternoon, reaching Baltimore by early evening and Philadelphia by nightfall. The precipitation field maintained spatial continuity rather than fragmenting into discrete bands. Radar returns showed consistent reflectivity, indicating sustained snowfall intensity across a geographic area spanning multiple states simultaneously. As the low-pressure center moved offshore but remained parallel to the coast, the snow shield continued expanding northward while maintaining coverage over areas where precipitation had already begun. By midnight on January 22nd, continuous snowfall extended from Virginia through New Jersey. Intensity remained steady. The system showed no indication of weakening or accelerating its forward motion. Accumulation began exceeding forecasted totals as precipitation duration extended beyond initial projections.
By dawn on January 23rd, measured snow depths exceeded 18 inches across the Baltimore-Washington corridor. Philadelphia recorded 20 inches. Snowfall rates sustained at 1 to 2 inches per hour through the morning. Accumulation depths surpassed the operational capacity of municipal plow fleets designed to manage 12-inch events. Roads could not be cleared at rates matching continued precipitation. Plows moved through arterial routes only to find previous passes reburied within hours. Salt application became ineffective as temperatures remained sufficiently cold and snow volume overwhelmed chemical melting capacity. Parking lanes disappeared under accumulation. Intersections filled with snow pushed from travel lanes, creating obstacles to traffic flow. Side streets and residential areas became impassable as plow prioritization focused resources on primary routes. The physical volume of fallen snow exceeded available space for removal. Measurements reached 30 inches in suburban Maryland. The storm continued without pause. Road closures began Friday evening and expanded through Saturday. The Pennsylvania Turnpike closed. Interstate 95 through Maryland became impassable. Virginia declared a state of emergency and implemented travel bans. New Jersey suspended transit operations statewide.
New York City announced subway service reductions, followed by complete suspension Saturday afternoon. Amtrak canceled all Northeast Corridor rail service. Regional airports ceased operations, as runways could not be maintained in clearing condition. Bus networks stopped running. The transportation infrastructure that enabled metropolitan function became completely inoperative. Hundreds of thousands of vehicles were abandoned on highways and surface streets, buried under continuing snowfall and obstructing any potential clearing operations. The corridor experienced simultaneous transportation paralysis across all modes and jurisdictions. No alternative movement capacity existed. The urban system relied on mobility that no longer functioned. 24 continuous hours of snowfall at high intensity had eliminated all transit options.
Electrical transmission lines accumulated snow and ice loading. Wind gusts to 50 miles per hour in coastal areas stressed infrastructure already burdened by precipitation weight. Power outages began sporadically Saturday evening and expanded overnight. Utility crews could not reach affected areas due to road inaccessibility. Repair vehicles became trapped or could not deploy from staging areas. Substations in outlying areas lost connectivity as access roads remained uncleared. At peak impact, approximately 200,000 customers across multiple states experienced power loss. Duration extended beyond typical restoration windows because personnel and equipment could not move through the transportation network. Hospitals operated on backup generator capacity. Heating systems in residential and commercial structures faced prolonged outages during temperatures in the teens Fahrenheit. Water treatment facilities maintained operations but faced staffing constraints as employees could not travel to work sites. The interdependency between mobility and service provision became absolute. Infrastructure required human intervention that required transportation that no longer existed.
From January 23 through January 25th, the urban corridor remained immobilized. Baltimore recorded 29 inches of snow. New York Central Park measured 27 inches. Newark registered over 30 inches. The accumulation blanketed an area containing more than 80 million people across 7 states and the District of Columbia. No through traffic moved on Interstate 95 for 48 hours. All major airports remained closed. Rail service stayed suspended. Cities issued states of emergency and implemented travel bans enforceable by citation or arrest. The corridor that normally processed millions of daily trips across all transport modes registered near zero mobility. Commerce stopped. Retail access ceased except where individuals could reach stores on foot through deep snow. Medical facilities operated on emergency staffing only. The immobilization was complete, simultaneous, and prolonged. Recovery could not begin until precipitation ended and equipment could be deployed, which required the snow to stop falling and sufficient time for initial clearing to restore basic access.
Official records documented 55 fatalities directly attributed to the storm across affected states. Causes included cardiac events during snow removal exertion, vehicle accidents, hypothermia, and carbon monoxide poisoning from improper generator use or vehicle exhaust in enclosed spaces. Emergency medical response times increased substantially due to road conditions preventing ambulance access. Hospitals reported elevated patient volumes related to cold exposure and exertion injuries once transit resumed. The storm directly affected approximately 85 million people through transportation shutdown, power loss, or service interruption. Economic impact estimates exceeded $3 billion, accounting for lost commerce, infrastructure damage, emergency response costs, and snow removal operations. Measured snowfall totals placed the event among the largest winter storms in the observational record for the affected urban areas. The combination of accumulation depth, geographic extent, and population exposure created a corridor-wide immobilization event without modern precedent in duration and impact severity.
Snow removal operations began at full scale on January 25 as precipitation ended and equipment could be deployed systematically. Priority focused on hospital access routes, emergency service corridors, and primary arterials. Residential streets remained uncleared for multiple days in many jurisdictions. Heavy equipment moved continuously for 72 hours to restore basic road network function. Rail systems required track clearing and inspection before resuming limited service. Airports reopened gradually as runways were cleared and aircraft de-iced. The volume of snow required disposal beyond normal roadside piling. Dump trucks transported snow to designated disposal sites. Full restoration of normal transportation capacity required a week. Some secondary roads in suburban areas remained partially obstructed for 2 weeks. The recovery phase involved thousands of personnel and hundreds of pieces of specialized equipment operating around the clock. Coordination across multiple municipalities and state agencies followed established emergency protocols scaled to unprecedented operational demand. The National Weather Service classified the January 2016 blizzard as a Category 4 storm on the Northeast Snowfall Impact Scale, indicating crippling impacts across a major metropolitan area. Official documentation recorded the event under the designation Winter Storm Jonas. Meteorological analysis confirmed the storm resulted from favorable atmospheric conditions that sustained high precipitation rates over an extended duration, while the system remained nearly stationary relative to the densest population zones. The event entered institutional records as a benchmark winter storm for the region, referenced in infrastructure planning documents and emergency management protocols. Snowfall totals, duration, spatial extent, and impact severity became archived data informing future preparedness standards. The storm's documentation exists as measured quantities, geographic coordinates, and casualty statistics preserved in federal and state databases. Winter Storm Jonas remains cataloged as the event that immobilized the eastern urban corridor for 3 days in January 2016.